Yes, dear, tell.
Will you record this lecture?
Yeah. I'm going to record it.
Okay, thank you, doctor.
But don't sleep, okay? Yeah?
Yes, no problem. I just want the lecture.
Okay. Good morning, everyone. Welcome to the lecture. Can you see this slide? It's written Chemi 220 and all that.
Yes, doctor.
Okay, you can see the slide. Okay. Now, actually, this lesson is basically related to bonding and isomerism. And this is just the review of Chemi 102. Exactly the same thing. Everything you studied in Chemi 102. Okay. Just we will have a brief introduction on this periodic table. You know, in the periodic table, there are 18 vertical columns called groups, right? There are, come on, tell how many columns are there?
18.
18. Okay, these columns are called groups. You know that. Respond.
Yes.
Okay. Groups total, there are 18. One starting from 1. This is the last group. Then we have how many periods are there? Horizontal rows. How many are there? Kamil?
7.
7. This all of you know. Now, something called valence electrons. I hope you know this. Do you remember?
Yes.
Do you remember?
The electrons in the
Yes.
outer
Yes,
shell.
electrons present in the outermost shell. Yes. In the outermost shell. Now, there is some relationship between the group number and these valence electrons. Do you know that relationship? Do you know?
The group number is the same number of atoms in the outer shell.
No dear. No dear. See, if
Except
you go
for 10 and onwards.
group 1 elements, see, the outermost shell will have, say, 1 electron. Group 2 elements, outermost shell will have 2. Group 13 elements, outermost shell will have 3 electrons. 14, 4, 15, 5. It goes like that. Did you get it? So group 1 elements have 1 valence electrons. Group 2 elements 2. Group 13, how many I told you? 3. Here 4, 5, 6, 7, 8. Okay. Now, this group 18 elements, they have a specific name. Do you know that?
Noble gases.
Noble gases. All of them are gases. They are called noble gases. All noble gases have 8 electrons in the valence shell except
helium.
Except helium. Helium has, see, Kamil only 2 electrons. Okay. So noble gases have 8 electrons in the valence shell. 8 electrons means octet is complete. Octa means 8. So they are stable. You know, stable means mustakar. They do not take part in bond formation. They don't give electron, or they don't take electron, or they don't even share electrons. Is it okay? You understood what I meant?
Yes, doctor.
Okay, all of you understood, right?
Yes.
Okay, so now, but all other elements Either they can give electrons or they take electrons, or sometimes they share electrons. For example, group 1 elements, that means these elements from this group, all these elements, they have except hydrogen. Hydrogen shows a few exceptions. Other than that, all these elements have the tendency to lose 1 electron. For example, we are taking sodium and chlorine. Sodium is from group 1. Cl is from which group?
17.
17.
It's group 17. See, Cl is from group 17. Now, Na has 1 electron in the valence shell, so it has a tendency to lose that electron. So what happens is Na will lose 1 electron and it will form Na plus 1 electron. You understood why Na plus? Because after losing 1 electron, it attains positive charge. Positively charged species is called, there is a name for that. Do you remember?
Cations.
Yes, they are called cations. Now, Cl has 7 electrons in the valence shell. It needs 1 more electron to become 8, right?
Yes.
So what does it do? What will it do?
It gains 1 electron from
Yes,
Na.
it takes 1 electron from Na. So when it is getting 1 electron, it will become Cl minus because electron is having a negative charge. So there is a specific name for this ion. Cl minus, negatively charged ion, has a specific name. What is it?
Anion.
Anion.
Yes, anion. Okay, so one is cation, other one is anion. Yeah. Now we have Na plus positively charged species. We have Cl minus negatively charged species. So now there is some sort of attraction. Attraction means what is it? Tajada? Correct? No? Correct?
Yes.
Okay, so there is some sort of attraction between Na plus and Cl minus. So this bond, this attraction between this cation, that means here it's Na plus, and the anion, it's Cl minus, is called what bond? Come on, ionic bond. Did you understand? Ionic bond is between ions. Is it clear? Is
Yes,
it
sir.
okay?
Yes, Doctor.
Okay, so that means actually Na plus, sodium is a metal, Cl is a non-metal. So metal and non-metals usually they form ionic bond. Okay, so this is one type of bond. Now, suppose we have just 2 Cl atoms. Cl1, 2, 4, 6 plus 1, 7. This chlorine also has 7 electrons. So to be stable, it needs 8, right? Right?
Yes, Doctor.
So what do they do? In this case, what do they do? Both of them need 1 electron.
They share their electron.
Yes, they share the electron. Sharing. So once they share electrons, what type of bond is present? What type of bond is formed?
Covalent.
Covalent bond.
Yes, it results in covalent bond. Number 2, this is first type ionic bond. This is second type covalent bond. Is it okay? You understood? Okay?
Yes, Doctor.
Yes. Now, this is what I did already. We did this, I already explained. Group number and the valence electrons. The noble gases have 8 electrons in the valence shell and they are obey-octet and they are stable. This we did, okay, I explained already. Now bonding classified into 2, ionic and covalent. Ionic, I told you, example which one? Na plus and come on, Cl minus. Here covalent, so this is attraction between the ions. Here covalent bond is obtained by
Sharing of electrons.
yes, okay, sharing of electrons. Now example, I told you Cl single bond Cl. Now these single bonds, different types of covalent bonds we have. Okay, this I taught last lecture, I don't remember. Did we do? No?
I think we stopped until here.
Oh, okay. You couldn't see anything, right? Now it's, can you read it clearly what I'm writing, or it's blurred?
Yes.
You can see clearly, right? Okay. So different types of covalent bonds. One is, see, look, first before I'll give example. Fluorine. F, which group of the periodic table fluorine?
17.
17. It has 7 valence electrons. So now what do they do? Both of them
share one electron.
Sharing. So you get single covalent bond. Single means 1. Okay. Now say oxygen. Do you know which group oxygen? Oxygen is in which group of the periodic table? It is 16. So it will have 6 valence electrons, right? So each one has 6 electrons. It needs 2 more. So what do they do? Yeah.
They share electrons.
Share. How many they share? Yes, they will share. See, look, so that results in what type of bond? Come on, tell me. Double covalent bond. Yes. Single, double. Okay, now, say for example, nitrogen. N, which group of the periodic table? Nitrogen, 15. How many valence electrons it has? How many valence electrons it has?
5.
5. So 1, 2, 3, 4, 5. Here also 5. So now you can
Share.
yes, share. So this results in what type of bond? Come on, tell me.
Triple.
Triple bond. Okay, so we have single bond, double bond, and triple bond. Okay, all of them are covalent bonds. Okay, now see, these electrons have some names. These electrons, do you know those electrons? The name of those electrons? Do you know, or you don't know? Okay, I'll write here one more time.
Sharing electrons.
Just a minute there. So look, fluorine, FF here. Okay, so we have shared electron or bonded electron or bonding electron. Okay, then this is one type. Second one is unshared electron. Non-bonding electrons. Mostly we use another term, lone pair of electrons. You remember this you studied in 102. Okay. See, in this case, how many electrons are shared? How many electrons? One bond means total how many electrons?
2 electrons.
2 electrons. 2 electrons or one pair. Did you get it? Okay.
Yes.
Now, unshared electron, opposite of shared is unshared, or opposite of bonding is non-bonding. But mostly we use this term, lone pair of electrons. So how many lone pair of electrons are there in this case? Tell me.
There are 6 pairs.
Yes, 1, 2, 3, 4, 5, 6 pairs. 6 pairs or 12 electrons. Okay, did you understand? Did you get it?
Yes, doctor.
Okay, so now here, can you tell me shared electrons, how many total?
There are 6 shared electrons and 2 lone
Yeah.
pairs.
Yes, okay. So 3 pairs, right? And 6 electrons. The other case, 2 pairs. That means 4 electrons. So I hope you understood these terms, shared electron, lone pair of electrons. Okay? Done? Is it okay? Dear students, is it okay? Yes.
Yes.
Okay, so now next, one more point I just want to tell related to lower classes. It's like electronegativity. Do you remember what electronegativity is? It is the ability of an atom to attract the shared pair of electrons or the bonded electrons towards itself. Can you read what I'm writing?
Yes, doctor.
Can you read? Is it okay? My handwriting is okay for you because since I'm writing on the slide, I mean on the screen, it doesn't come properly. Is it okay?
No, it's clear.
Yes, doctor, you can read it.
Okay. So this is the meaning of electronegativity. See, I'll illustrate it. Say for example, H and H, 2 hydrogen atoms. So here the shared electrons, one pair of electrons are shared. The position of those 2 electrons will be in the middle. Understood the meaning of that? Because it's these 2 atoms equally share those 2 electrons. Understood what I meant? Whereas suppose we have H and fluorine. Fluorine is more electronegative than H. The meaning is these shared electrons stay closer to fluorine. So fluorine gets show a negative charge and hydrogen gets small positive charge. This symbol means delta. Delta means it's small, okay? So that means in the first case, electrons stay in the middle. Whereas in the second case, electrons stay closer to fluorine. It's little far from hydrogen and it's closer to fluorine. So this is the meaning of the term electronegativity. Did you get it? Understand?
Yes.
Okay, so now one more point I want to mention. Moving from left to right in the period, electronegativity increases or decreases?
Increases.
Okay, maximum increases from left to right, right? From group 1 to group, come on, tell. Group 17. 18, no, because they don't take part in bond formation. Okay, the maximum is in group 17. Okay, left to right from group 1 to group 17. So group 17 elements have maximum electronegativity in a particular period. Okay, so in that case, which element is the most electronegative element? Can you tell me?
Fluoride.
Yes, it's fluorine. Okay, yeah. Now, do you remember the second most electronegative element? The most electronegative element is fluorine. The second most electronegative element, any idea?
Oxygen.
You forgot. Yes, dear?
Oxygen.
Yes. Fluorine, oxygen, nitrogen. This is just a hint. Can you read it as a word? Just read it as a word.
Phone.
Phone, yes. Phone means not the phone which you call. This is chemistry phone. Okay. Fluorine, oxygen, nitrogen. Fluorine is the most electronegative element. Second most is oxygen, then nitrogen. It goes like that. Okay. So now, moving down a group, what will happen to electronegativity? Come on.
It will decrease.
Electronegativity decreases. Okay. Yeah, okay. See, look, something is there on the slide. What's written here? If the electronegativity difference between the bonded atoms is more than 2, that bond is ionic bond. If it is less than 2, it will be covalent bond. And if it is 0, it's non-polar covalent bond. And the next sentence is polarity is expressed in terms of dipole moment. Did you understand something?
Yes, doctor.
Okay, all of you understood?
Yes, doctor.
See, I will give you an example. Look, NaCl. You don't have to by heart the values, okay? The electronegativity value is 0.9. Okay, Cl, the electronegativity value is 3. So what's the difference? Come on.
2.1.
Yes, 2.1. So it's more than 2. If it is more than 2, what type of bond is present in NaCl? Come on. Ionic bond. Okay, so then now. Suppose you have two Cl atoms. Cl, Cl. The value for Cl is 3. Here it is 3. So what's the difference? Come on. Difference is 0. Difference is the difference is 3 minus 3 is 0. Okay, so now suppose if it is H and H, again H the value is 2.1. You don't have to memorize the values, okay? You don't need it. The difference is again 0. Correct? Now suppose if you go for HCl, H 2.1, Cl it is 3. So what's the difference?
0.9.
Yes, 0.9. Look, all these bonds are, come on, covalent or ionic?
Covalent.
All covalent.
Covalent. Of which the first two, specific something. What is it?
They're non-polar.
Yes, the first two, I'll remove that. Just a minute. It's not moving. Okay. Anyway. See. First two non-polar covalent bonds and the last one is polar covalent bond. Okay. Yeah. Is it clear?
Yes, doctor.
This is covalent, this also is covalent, but this particular one is polar and this many are non-polar. Is it okay now? So the meaning is HCl, the electrons go closer to this. This will get little negative. This will get little positive. The molecule is polar, and polarity is expressed in terms of dipole moment. So it has, in the first case, there is no Cl2 and H2. Cl2 dipole moment is 0, right? Why? because they are non-polar.
shared
Yeah, so
equally.
don't think this is 0 and this 0. No, this is not the one. Okay, so dipole moment is calculated using another formula. Okay, not just by the difference. Okay, now HCl. What about HCl? It is dipole moment is not 0, right?
Yes.
Okay, not equal to 0. Okay, yeah. Next, this one is okay. Now, next question is, which one is more polar, HCl or HF? Tell me. Tell me.
HF.
HF. Why? Why?
Because there's a greater difference.
Mm,
And
yeah,
fluorine is
because, yeah,
more
because
electronegative.
yes, F is more electronegative than Cl. Okay, now next one, which one is more polar? NH bond in NH3 or OH bond in H2O? Okay, yeah. NH3, NH bond or OH bond, which is more polar?
OH.
OH. Why?
Because
OH.
oxygen is more electronegative
Yes,
than
oxygen
nitrogen.
is more electronegative. Okay. And now, so how to show the direction? Okay, yeah, the dipole moment. I will just show you. Just okay. See here, I told you Cl is more electronegative than H. So we express it like this. Did you understand the meaning? So that means it goes the arrow goes closer to or towards the more electronegative atom. In this case, how do you do? HF it goes, right? Understand?
Yes.
Okay. CH3F, again it goes like this. Now, when it comes to CH3OH, I'll just draw the low structure. CH bond is kind of non-polar. Its polarity is very less. So we go for CO and OH bond. O is more electronegative than C, right?
Yes.
Right?
Yes.
Okay, so it goes closer to this one. See? Right? Now, between O and H, which is more electronegative?
Oh.
Oh, so it goes this one. See? I hope you understood. That means electrons are going close to oxygen from both sides. Right?
Yes.
Okay, another one, CS3 and H2. Again, come on, tell me. Yeah? Which is more electronegative, C or N? It goes this way, it comes this way, right? Correct? From here it goes.
Doctor?
Doctor, I think you muted your mic.
Yeah, we can't hear you.
Doctor, I don't know if you intendedly muted your mic, but your mic is muted, it appears.
Is it okay now? Can you hear me?
Yes, doctor.
Okay,
Yes.
I think maybe all net issue. Yes, yes, okay. Now can you see?
Yes.
Can you hear me also?
Yes. Yes, doctor.
Okay. Yeah. So now, next. Did you see? These are, yes, you remember in schools, maybe you studied different types of orbitals. Even in 101 and 102, you studied s orbital, p orbital, d orbital, and all that. You remember that?
Yes.
Okay, so now we focus only on S and P. We don't need D and F because organic chemistry is mainly related to S and P, because carbon means we have only S and P. Organic means it's related to carbon compounds mostly. So now we focus only on these orbitals. So S orbital and P orbital. These are the shapes. Okay, can you tell me the shape of S orbital?
Spherical.
Yes, it is spherically symmetrical. Okay, this is spherical. There is a symmetry. It's spherical. Now, what about these shapes? P subshell has 3 p orbitals. You know that, right?
Yes.
P subshell has 3 p orbitals. One is px, the other one is py, the third one is pz. Okay. Now, the shape of p orbital. Can you tell me the shape of p orbital? It's called dumbbell. Okay, but actually all these three are not separately situated. It's all of them are together. Okay, they stay together. See, if I draw, it doesn't come neatly, but then I'll try. So one is like this, another one like this, third one like this. Did you get something? Did you get?
So they're intersecting, you mean?
Yes, all of them stay together. Okay, all of them are always together. So it will be like this. One is along x-axis. This is, say, it's y-axis, and this is through this axis, z. Okay, yeah, z I wrote like that, right? This is the actual one, all of them together. If I draw like, if it is shown like that, it's not clear. That's why it is shown separately. Actually, all of them together. Okay, because p subshell, one subshell has 3 p orbitals. No, it's like that. Okay, is it okay?
Yes, doctor.
Okay, so now next, this you studied in school, right? Yeah. Yeah, I'm not muted. You can hear
Yes,
me.
doctor.
Okay,
We
so
learned that before.
you learned all this. So you want me to explain or no need?
From my side, I think it's clear, but maybe some students will need that.
Okay, then I'll explain it. Okay, see, here, before we start, maybe you studied in Arabic. Before we start, I'll tell you the meaning of the term overlapping. Overlapping means merging, mixing. Okay. Okay, yeah. Then two types of merging possible. One merging through the axis, it's called axial overlapping. And it is, the other one is perpendicular to the axis. It's called lateral overlapping. Did you get or not?
Yes, doctor.
Okay, see,
Yes.
overlapping. We have overlapping means merging, mixing. Okay, so one is called axial overlapping. Other one is called What does it say? Can you see? Lateral overlapping. Okay. Yeah. So one is through the axis, the other one is perpendicular to the axis. That's the meaning. Look, we have two s orbitals, s1 here, another one. So we merge them. Remember one thing, when you mix them completely, they will not merge. You understand what I meant? You cannot mix this completely with this one. Why? Because after a certain distance, you cannot bring them closer because this one has a nucleus, this also has a nucleus. This nucleus will repel this nucleus, that is tanafir. Okay, so you cannot bring them very close. You can bring them to a particular distance. Okay, that distance is the bond length that you will study later on. Okay, so this is the overlapping. Did you understand? S is overlapping. That will result in this one. Is it clear? This is for hydrogen atom. Okay, so it will result in the formation of hydrogen molecule. Leave that part. So I just wanted to show you the meaning of SS overlapping. And this overlapping is a proper overlapping that will result in this type of bond. Can you read it? Can you read it?
Sigma
yes.
bonds.
Yes, it's called sigma bond. Now, another overlapping. Look here, S, come on, S and P. Again through the axis. So what type of overlapping is that? Axial overlapping. So this is S and P. So that also will result in what type of bond? Sigma bond. Is it okay? Did you understand?
Yes.
Okay, so that means SS sigma, SP also sigma, right? Now, what is left? PP overlapping. See, I told you we have 3 p orbitals, right? Okay. Okay. Hello. Yes.
Yes,
I
Doctor.
told you this one. I'll go back to the previous slide, and before that, I just wanted to show you this one. See. If you can't hear my sound, you tell me, okay? I will maybe by mistake it will go in the mute mode, okay? See, look here. This is one set of p orbitals. So px, you listen here, okay? Otherwise you won't understand. This is px, green colored one. Then py, it is what's the color? What color I used?
The red one.
Red one, and PZ, it's the black one. So this is for one. And we have another atom having similar PX, PY, PZ. Now what happens is, this PX will overlap with PX. Did you get the point? Did you understand? These two will overlap through the axis. Can you see the axis of the bond? Through the axis, they overlap. Okay, so this overlapping is axial overlapping. This axial overlapping will result in what type of bond?
Sigma.
Sigma bond. Okay, so don't forget, since px is on the axis, okay, px plus px. So that means this is one px. Can you see? Px and another px, they come through the axis. So px plus px will give you sigma bond. Did you understand? Is it clear?
Yes.
Is it clear? Okay. Now look at this py. Py is perpendicular to the axis of px, right? Perpendicular. Did you see? Did you see?
Yes, Doctor.
Okay, so this is perpendicular to this axis. So py, we have one py and we have another py, two red ones. These two will overlap. This overlapping, is it through the axis?
No, it's lateral.
No, it is perpendicular to the axis. So this is what type of overlapping? This overlapping is called, this merging is called
Lateral.
a lateral overlapping, or we call sidewise overlapping. Oh, I forgot to tell you, axial overlapping is otherwise called head-to-head overlapping. head-to-head overlapping. This is sidewise overlapping or lateral overlapping. This sidewise overlapping, they cannot closer. Can you see? This is not very good overlapping. Merging is partial. That will result in weak pi bond. Sah?
Yes, doctor.
صح دكتور.
Okay, so PY and PY. See, in the exam, you lose marks. So you just listen carefully, okay? Here, PY and PY, you get pi bond. Now, look at this one, PZ. All these three are mutually perpendicular. So this PZ also is perpendicular to PX and PY. So we have PZ here. We have one more here, PZ, one more orbital. Now these two will overlap. This is what type of overlapping? Tell me, axial or other one?
Lateral.
Which one? Yes, lateral overlapping. That also will result in what type of bond?
Pi bond.
Pi bond. So in short, you just listen. I'm going to ask you questions. If x-axis is taken as an internuclear axis, px and px will give sigma bond, py will give pi bond, pz will give pi bond. Suppose if y-axis is taken as internuclear axis, if y is taken as internuclear axis, py plus py will give
Sigma bond.
Sigma bond.
yes, and px plus px will give
Pi bond.
okay, pz and pz will give
Also pi bond.
okay, yes, okay. Suppose if it is z-axis is taken as internuclear axis, which one gives pi and which one gives sigma?
PZ and PZ sigma. And the rest
Okay.
pi.
Yeah, pi. So it is you understand, right? It depends on how we take. So in the exam, be careful when you answer the questions, because last semester many people made it wrong. Okay. Okay, I think it's clear for you, right? Right?
Yes.
Okay,
Doctor.
so now this is what better diagram, okay? See, PP overlapping two types. One is axial or head to head. The other one is lateral, or I told you another name for this lateral overlapping.
Sideways.
Yes. Okay. Yeah. Is it clear for you? Understood,
Yes,
right?
doctor.
So this is pi bond. This is okay. And now, which bond is stronger?
Sigma is supposed to be stronger, right?
Yeah, sigma. You know why sigma bond is stronger? Because can you tell me?
Because the bonds are closer.
Yeah, bonds means the
Overlapping is more overlapping.
overlapping. See, they can merge properly. Efficient overlapping. Okay. Okay. Do you have any doubts? Any questions? Did you understand everything?
Yes, doctor. Yes, doctor. It's all clear.
Yeah. Okay. Now there is something called hybridization. Do you remember? Hybridization.
Maybe some help from you will make us remember, inshallah.
Okay. So hybridization means I'll give you examples, then you will be able to remember SP, SP2, SP3, SP3D, SP3D2. Do you remember now? Okay, anyway, leave that. Okay, I'll tell you the meaning. Okay, later on you will get it. See, if we have suppose one s orbital, you know the shape of s orbital, okay, and you have another one, p orbital. This is a p orbital, one is s orbital. We mix them. Hybridization means mixing of orbitals having different shape and slightly different energies. Okay, You understand what I'm telling, right? This is for the same atom. This mixing of orbitals of within the same atom, it is taking place. You understand what I meant? Suppose if we have carbon, carbon has s electron, carbon has p electron. Those orbitals we mix. Okay, so you will get equal number of hybrid orbitals. We mix 2, we get 2. See, you understand what I meant? After mixing, there is no difference as S or P. Both of them are equivalent. Both same shape, same energy. So this is called hybridization. Did you understand? See, when I draw, it will never come properly. Look, before hybridization, this is spherical in shape. This is dumbbell in shape. After hybridization, these two should be equal. Okay, when I did, it's not coming properly. So only one lobe is there. The other lobe is diminished. Did you see? See, before mixing, it's like this. Okay, so I'll make it like this. This is before mixing. After mixing, it's like this. Now it's clear for you. Understand? Okay,
Yes.
so that means these two, but now there is no difference as S and P. So this hybridization is called sp hybridization because we mixed one S with one P. So now the whole electron density is on one lobe. The electron density full thing is transferred to one lobe so that overlapping will be efficient. So this is the meaning of hybridization. Is it clear for you? Is it okay? So before mixing, they have different shape, different energy. After mixing, same shape, same energy. Okay?
Yes, doctor.
Hello.
This is happening same molecule, right?
Yes, the same atom. We are going to do it in detail. Okay. Suppose if you are going for carbon atom, carbon has 1s2, 2s2, 2p, 2. So we mix s orbital of carbon with p orbital of carbon. Not like the other one, not the overlapping. This is not the overlapping. Okay. After that, they will overlap. Understand what I meant?
Yes, doctor. Yes, understood.
Okay, so it's I didn't teach in detail, so next class it will be clear for you. But please you revise and come next class, okay? So it's good for you. Actually, this course is very easy. Easily you can score full mark, but then if you take it lightly, you will not get marks. Okay, next week we will start the lab, and yeah, it's very important to attend the lab. Okay, I will send the syllabus today itself. Okay, so it's okay. Yeah.
Okay, doctor. Thank you.
Okay, bye. Yes.
Inshallah,
Okay,
thank
I
you,
hope
doctor.
if you have any question, you can ask. Okay.
Have a nice day. Thank you.
Yeah, you too have a nice day, my dears.